Welcome to our discussion of balancing chemical equations. In this lesson, we'll identify balanced and unbalanced equations, explain the importance of balancing chemical equations, and learn how to balance our own chemical equations. To begin, let's take a look at this reaction. I have hydrogen gas combining with oxygen gas to form water. On my reactant side, I have 2 hydrogens and 2 oxygens. On my product side, I also have 2 hydrogens, but only 1 oxygen. So what happened to that other oxygen? Well, nothing, because according to the law of conservation of matter, matter is neither created nor destroyed. So that means we can't lose atoms. I can't start with 2 oxygens and end up with only 1 oxygen. I have to balance my equation so that I'm ending with the same amount of atoms that I started with. So now the question is, how do we balance these equations? Well, the first thing to understand is that we can only change the quantity of our substances. We cannot change their identity. And so to do that, we can only change the coefficients, the big numbers out in front of our substances and compounds, not the smaller subscripts. So for example, if I were just to add a subscript 2 to my water, I would now have 2 oxygens on my reactant side and my product side, but now instead of my product being water, my product is hydrogen peroxide. So I've completely changed the identity of my product. So let's practice actually balancing this equation. So the first thing I'm going to do is I'm going to draw this dashed line down underneath my arrow to separate my reactants from my products. And now I'm going to list all of the elements present in this reaction. And for this reaction, it's just hydrogen and oxygen. So I'm going to tally how many of each of these elements I have on my reactant side and my product side. So on my reactant side, I have 2 hydrogen and 2 oxygen. And on my product side, I have 2 hydrogen and 1 oxygen. So we can see that our hydrogen are already balanced. It's our oxygen that are not. So we should start there. So I need 2 oxygens on my product side since I have 2 oxygens on my reactant side. So the only way I can do that is by changing the coefficient in front of my H2O. So since I need 2 oxygens, I'm going to make that coefficient a 2. And now I have 2 oxygens because remember those coefficients apply to everything to the right. But that also means I've now changed the number of hydrogens in my water. Instead of 2 hydrogens, I have 4 hydrogens. So in the process of balancing my oxygens, I actually unbalanced my hydrogens. So I need to go back to my reactant side and make it so that I have 4 hydrogens on my reactant side to balance out the number of hydrogens I now have on my product side. And that's pretty easy. I can do that by just adding a coefficient 2 in front of my H2 because 2 times 2 is 4. So now I have 4 hydrogens on my reactant side and 4 hydrogens on my product side. So I'm going to do one quick check to make sure that everything's balanced. I've got 4 hydrogens on the reactant and product side, and I've got 2 oxygens on my reactant and product side. So this equation is now balanced. And notice to do that, I only changed the coefficients. I did not touch any of the subscripts. The last thing to note is that our coefficients are actually ratios. So in this reaction, I have a 2 to 1 to 2 ratio, meaning that if I have 2 molecules of hydrogen gas combined with 1 molecule of oxygen gas, I'm going to get 2 molecules of water. So if we change our coefficients in any way, if we change one of our coefficients, we have to change all of the rest of the coefficients in the same way. So for example, if we have 4 molecules of hydrogen gas, that means that we need 2 molecules of oxygen gas to combine with it in order to form 4 molecules of water. So whatever you do to one coefficient, you need to do to the rest of the coefficients in a balanced equation to maintain that ratio that is going to be unique to a particular chemical reaction. So before we start balancing and doing some practice, here are some tips and tricks that will often help you as we balance lots of different types of chemical equations. All right, so let's take a look at this example. So the first thing we notice is that it's not balanced. I have 2 nitrogen on my reactant side, 1 nitrogen on my product side, 2 hydrogens on my reactant side, and 3 hydrogens on my product side. So I am not balanced at all. So the first thing I got to do is draw that little dashed line, and then I'm going to write all the elements that I have in this reaction on the left, so just nitrogen and hydrogen. And then I'm going to tally everything up so I know how many of each element I have on my reactant and product side. And now, according to my tips and tricks, I'm just going to start at the beginning and move all the way through my reaction first and try to balance everything going in one direction from start to finish, from left to right for my reaction. And then if I need to fix anything, then I'll loop back. So let's start with nitrogen first. So if I have 2 nitrogen on my reactant side and 1 nitrogen on my product side, if I give my product a big 2 coefficient, now my nitrogens are balanced. So now I've got to keep going and balance my hydrogens. So on my reactant side, I still only have 2 hydrogens, but now on my product side, since I added that coefficient to balance my nitrogens, I have 6 hydrogens. So I need to go back and I need 6 hydrogens on my reactant side. So the easiest way to do that is add a big 3 coefficient in front of my hydrogen, because 3 times 2 is 6, and that will change my amount of hydrogens on my reactant side. So now I have 6 hydrogens on my reactant side and 6 hydrogens on my product side. So I'm going to do one quick check to make sure everything's balanced. So on my reactant side, I have 2 nitrogens, and on my product side, I have 2 nitrogens. And on my reactant side, I have 6 hydrogens, and on my product side, I have 6 hydrogens. So this reaction, this equation is now balanced. All right, let's try one a little bit harder. Let's look at a combustion reaction. So right off the bat, I can see that I have 3 carbons on my reactant side and 1 carbon on my product side. So I'm clearly not balanced. So I'm going to write my dashed line, put in my elements and the quantities for each on my reactant side and my product side. And now I'm going to move through my reaction or my equation from right to left, one at a time, and balance all the way through, and then come back and rebalance anything that I need to. And it also mentions on our tips and tricks list that if we have a reaction with only carbon, hydrogen, and oxygen, that we should balance it in that order. And that is the order that we're going to balance it in, because that just, in this case, just happens to be the order that my elements are in this particular equation. So let's start with our carbon. I've got 3 on my reactants and 1 on my product side. So I need to have 3 on my product side to match. So I'm going to draw a big 3 coefficient next to my CO2, and that's going to take care of my carbon. So I'm going to go back and balance my hydrogen. So I have 8 hydrogen on my reactant side and 2 hydrogen on my product side. So I need to have 8 hydrogens on my product side in order to balance. So I'm going to do that by putting in a big coefficient 4. So now I have 8 hydrogen on my reactant and product side. So I'm balanced there. But now our oxygen is where it gets a little tricky. So I've added some coefficients. So I've actually changed the amount of oxygens that I have. So I still only have 2 oxygens on my reactant side, but now in my CO2, I have 6 oxygens, and in my water, I actually have 4 oxygens. So 6 plus 4 equals 10. I now have a total of 10 oxygens on my product side. So I need to do something with my oxygen on my reactant side in this case in order to get that to be balanced. So I have 2 oxygens already. So if I make this a big coefficient 5, now I have 10 oxygens on my reactant side and 10 oxygens on my product side. So always be careful, make sure you're counting all of the elements in every compound in which they exist when you're totaling up your amount of that element on either your reactant or product side. So one last check to make sure that I'm totally balanced. I have 3 carbons, 8 hydrogens, 8 hydrogens, 10 oxygens, and 10 oxygens. So we are balanced. So next up, we have a decomposition reaction with potassium chlorate breaking down into potassium chloride and oxygen. So when we set this all up, we notice that everything's balanced except our oxygen. But what's particularly tricky in this case is that I'm going from an odd number on my reactant side to an even number on my product side. So this is going to be quite difficult to find a way to get them to both be odd or both be evens. So that's why we have to bring in our very last tip and trick on our list, the fraction method. So notice that our first tip and trick says that our coefficients must be in the lowest whole number possible. So ultimately our coefficients need to be in whole numbers, but we can use a temporary fraction to help us get to where we need to go. So if I have 2 oxygens on my product side and 3 oxygens on my reactant side, what times 2 equals 3? Well, the only thing that I know of that I can multiply by 2 to get 3 is 3 over 2. So that's what I'm going to make my coefficient for my oxygen on my product side. I'm going to make it 3 over 2. But we just said that this fraction can only be temporary, that we need to get rid of that fraction so it can be a whole number, because all of our coefficients ultimately need to be whole numbers. So my oxygens are now technically balanced. I have 3 and 3, but I need to make that fraction whole. So I need to manipulate this entire ratio. I need to manipulate all of my coefficients to get rid of that fraction. So the only thing I know of right off the bat, right offhand, that I can multiply 3 over 2 by to make it a whole number is 2. Because if I multiply 3 by 2 by 2, I just get 3. But if I multiply my 3 over 2 by 2, I have to multiply all the rest of my coefficients by 2. So I'm going to end up having 2 potassium chlorates, 2 potassium chlorides, and 3 oxygens. So now I clean things up a bit and do a quick check to make sure that I'm balanced. So I've got 2 potassiums, 2 potassiums, 2 chlorines, 2 chlorines, 6 oxygens, and 6 oxygens. So I'm balanced. And I'm in the lowest whole number ratio possible for my coefficients. So I'm even good to go there. No more fractions. Now let's take a look at one final example that involves polyatomics. So already this equation looks really complicated and overwhelming. But if we notice, we've got a lot of polyatomics going on, a lot of our polyatomic ions. So if we look at our tips and tricks list, it says to keep polyatomics together or change them to a variable. And that's as long as your polyatomic occurs on both sides of the equation. So as long as you have the same polyatomic on the reactant and the product side, you can change it to a variable to make your life a little easier. Since these polyatomics are going to stay together, we can just treat them as a unit. So let's simplify this equation a little bit and let's just assign variables to the polyatomics that we have going on here. So our first polyatomic is sulfate, SO4, and our second polyatomic is hydroxide, OH. And we have both of those polyatomics on both sides of the equation, on our reactant and product side. So I'm going to make our SO4 X, our sulfate X, and I'm going to make our hydroxide Z. You can choose whatever variables you like. Those are just the first two that I chose. So I'm going to rewrite this equation, substituting those variables in everywhere I have that particular polyatomic. So as you're translating these polyatomic ions into variables, make sure you're paying attention to the subscripts and that the subscripts that belong with the polyatomics are being translated into your variables, but the subscripts that are outside of your polyatomics are staying. If you don't keep these outside subscripts, it's going to be really difficult to balance your equation. So now that it looks a little better, we're going to set this up as usual with our dashed lines and all of our elements and our quantities on both sides, and then we're going to just start balancing from left to right, all the way from aluminum to Z. All right, so on our reactant side, I have 2 aluminums and 1 aluminum on my product side. So I'm going to write a big coefficient 2 on my product side. So now I have 2 aluminums and 2 aluminums. So I'm going to keep on going. For my X, I have 3 X's on my reactant side and 1 X on my product side. So I'm going to write a big 3 coefficient in front of my CAX to balance out my X's. Now I have 3 on my reactant side and 3 on my product side. Next up is my calciums, and I just have 1 calcium on my reactant side. But on my product side, since I added that coefficient, instead of having 1, I now have 3 calciums. So I actually need to go back and balance my calciums on my reactant side. So I'm going to add a big 3 in front of the calcium on my reactant side. So I now have 3 calciums on my reactant and product side. And finally, I need to go back and balance my z's. So I've changed a bunch of coefficients, so I've actually changed the amount of z's that I have on both my reactant and product side. So I'm going to need to do some updating. So if I take a look at my reactant side, I now have, with that 3 coefficient in front of that compound, I now have 6 z's. And on my product side, with that 2 coefficient in front of the compound, I have 6 z's as well there. So my z's have actually been balanced. So now that I've gone through and balanced all of my elements once, I'm going to go back through one more time just to double check to make sure that everything is balanced, since I did change quite a few coefficients. So my aluminums, I have 2 aluminums and 2 aluminums, 3 X's and 3 X's, 3 calciums, 3 calciums, 6 Z's, and 6 Z's. So I am in fact balanced. But remember, this equation isn't our actual equation. This is our equation with our variable placeholders for our polyatomic ions. So in order to totally finish this up, all I have to do is rewrite these coefficients from my shorthand equation back into my original equation where they belong, and then do one quick double check, and I should have a nicely balanced equation. So when I write these coefficients back up into my original equation, I have 2 aluminums, 2 aluminums, I've got 3 sulfates, 3 sulfates, 3 calciums, 3 calciums, 6 hydroxides, and 6 hydroxides. So I am balanced. So this is a good example of how you can simplify your equations that have polyatomic ions in them. And this concludes our discussion of balancing equations. Bring any questions you have with you to class.